Okay, so in this video, we're going to talk just about the setup for the game. The setup includes these two technologies, Haxe and Node.js. They seem quite opposing because Node is just for JavaScript and Haxe is for its own language, but I use something called Lix to bring these two technologies together in such a cool and awesome way that helps me manage the game better. Now, what Lix does differently from Haxelib, which comes packaged with Haxe, is it downloads all your dependencies into a folder, your home or root folder on your machine, so that you can see them, and you can also have different versions of the same dependency. So if you look at this, I've got two versions of Haxe, as you can see, 4.15 and 4.21, and loads of different dependencies as well. This is useful because I can see what's here and I can delete things I don't use, but also if I have multiple projects that use the same dependencies, they can all go to the same folder and grab that dependency from here instead of putting it in a different place. There are also other advantages to using Node.js for my Haxe project, and these are some of them: versioning, changelog management, and automatic deployments. Now, just a heads up, there won't be a lot of gameplay in this video, as I'll mostly be talking about tech setup stuff. So if that's what you came here for, then I'm sorry, you're going to be really disappointed. But if you're into this geeky, techie setup stuff, then stick with me, and I promise you won't be disappointed. Okay, so let's talk about how Node.js helps with the versioning of my Haxe game. So this is the repository, and these are all the files I have. And as you can see, there is a haxerc file. And in this haxerc file, you'll see that's where the version of Haxe is. So currently for the game, it's Haxe 4.15, because that's the version that supports haxeflixel. If I need to change it at any point in the future, I just change it in this one file, and my whole project will benefit from a newer or older version of Haxe. And as you can see, the libraries are scoped to my project, and so is this version. So if I have another project that has a different version of Haxe, I can jump to that folder and it will load up that specific version. There's also a haxe_libraries folder, which contains all the libraries I use for this game. This is helpful for many reasons, but it also helps me know what versions I need for the project. As you can see, these are the 5 dependencies that I have for my game, and in each file, it will show me the version of the dependency or library that is needed for the game to run. Finally, we have a package.json file, which is needed for all Node.js projects. And this contains a number of things, including the name, description, the main source. But the most important thing for this part of the video is that it contains the version of the project, which can be displayed in the game with this code. On line 11, I'm loading the package.json file, and I can display the version number in the game so that if I have a newer version, the player can see that their version is out of date. In the bottom right-hand corner of the game, it's displaying the version from the package.json file. Next, let's talk about changelog management. So in the repo again, I have a file called changelog.md, which is a markdown file. If you don't know much about Markdown, it's basically a really cool way to format text that can be read by the machine and displayed by specific programs. But if you don't know what it is, don't worry about it too much. This file essentially is automatically generated, and I don't have to edit this manually, and it will contain information about the game that has been fixed or changed. So here is what it contains right now. It's a bit empty at the moment, but as you can see, it has the version of the game currently, which is 0.0.1, the date it became that version, and some notes about how this file was generated. I use a library called standard version to create this file. To update the version of the game, I can run one of these 3 commands. So this is the repository for standard version, the library that I use to automatically create a changelog and add changelog information about the game. It's a JavaScript library, so I installed it with Node.js, but I can use it in my Haxe project. Now, the way this works is it reads the commits that you've written, and if you don't know what a commit is, it's basically a message for the version control system you're using to tell it when you've made a change to the file. So this reads the commits, and you have to write your commits in a certain way for it to read it and know which one is a bug fix, which one is a feature, and which bits to ignore. And the way you write your commits so that this can understand it is in something called conventional commits. So these are some of the commits that I've used on the project. Each commit has a prefix with a colon. So here there's fix, CI, feat, chore, and chore. So these are the 5 commits. And the standard version only reads the fix and the feat prefixes. So if it's feat, it means it's a new feature. So add that to the changelog. And if it's fix, it means it's a bug fix. So here is an example from the Angular project, which is a JavaScript framework. And here you can see that there's a section for feature or features, bug fixes, and also the version of the project in the top left-hand corner. What this also does is automatically create Git tags for the project, so you can go back to it in a certain version. Okay, and finally, let's talk about automatic deployments. So before I continue, what I mean by automatic deployments is the fact that the game can be deployed or built to a certain environment without me doing any work. I'll explain more about that later. But here, let's look at the file structure of the game. There is a folder called .github, and in that folder is another folder called workflows. In the workflows folder, there is a file, and what this file does is it uses something called GitHub Actions to automatically deploy my game that I've made to the website, to the internet. And this happens all the time. I make a push. So this is when I make a commit and I push my change to GitHub. This is all done using my command prompt or terminal. And the way this works is it has an operating system, which is in a container. I don't want to explain too much about this, but it has a container in the cloud and it will take my game and run it on that container. Now this container already has Node.js installed. So as you can see from lines 14 to 17, what it will do is it will install Lix. Lix will download all the dependencies, so it will download Haxe, haxeflixel, OpenFL, Lime, all that stuff, and then build my game, which would then be on the website for anyone to go ahead and play the version that I've just deployed. If you want to check out the game on the GitHub pages URL to see it's all working, to see I'm not making this stuff up, then check out this link where you can see the game running and you can play with it. It's in a very early stage, so don't expect it to work well, basically. And that's pretty much it. So you can see with the power of Node.js in a Haxe game and Lix to combine those two bits of technologies together, I can do a lot of things automatically. So I can change the version of the game. I can have a list of versions for libraries and Haxe, and that can be changed automatically. I can also have an automatic changelog, which will display whenever the game changes. So players can have a look and see what updates have been made, and the game will automatically be deployed to the internet whenever I make a change.